Inside the port of Rotterdam, engineering at the intersection of innovation and necessity opening, the maritime nexus at the mouth of the Rhine River where it meets the North Sea lies the port of Rotterdam, a vast network of docks epitomizing modern engineering. As the largest port in Europe, it is a crucial artery for global trade. Ships from around the world arrive at its facilities, showcasing an engineering marvel that reshapes traditional maritime infrastructure. The story of the Port of Rotterdam invites exploration of what has been built and the myriad challenges faced by engineers over decades. Context: the need for expansion. The Port of Rotterdam's origins trace back to the late 13th century, facilitating trade for local merchants. The mid-19th century brought industrialization, spurring dramatic growth. The Industrial Revolution posed challenges, increasing ship sizes, rising trade volumes, and demands for efficient logistics. After World War II, the port underwent significant reconstruction, and the subsequent Cold War era saw a boom in trade along Europe's northern routes. Adapting to larger ships and modern transport methods became essential. To maintain its competitive edge, the Port of Rotterdam needed to expand in both capacity and efficiency. The engineering challenge: expanding a complex ecosystem. The task was not just to increase capacity, but to navigate environmental regulations, economic factors, and geographic limitations. Climate change posed unprecedented challenges, including rising sea levels and intensified storms, making it essential for any expansion to respond to these threats. The engineering focus turned to key projects aimed at enhancing the port's infrastructure. Among them was Maasvlak 2, an ambitious land reclamation initiative to extend the port into the North Sea, envisioned as a space where technology and ecology coexist. Step-by-step explanation of the solution: Maasvlak 2 launched in the early 2000s. Maasvlak 2 aimed to add 2,000 hectares to the port, supporting container terminals and creating a logistics ecosystem. The engineering solution followed several steps: 1. Feasibility studies and design. Comprehensive studies outlined requirements, predicting vessel types and cargo volumes. Designs incorporated advanced modeling to assess wave movements and sediment transport. 2. Dredging and land reclamation. Extensive dredging sourced materials for land reclamation. Sand was extracted and transporting using a unique tubeway system to preserve integrity. 3. Building the breakwater ***, a robust granite breakwater protected against sea forces, designed to endure storm impacts and erosion. 4. Creating the compacted land. Layers of sand were compacted using advanced machinery to create a supportive base for structures, accommodating massive container ships. 5. Establishing infrastructure. Necessary infrastructure like roads and utilities aligned with logistic needs, while automatic cargo handling systems enhanced efficiency. 6. Environmental considerations. The Port Authority prioritized ecological impact, collaborating with environmentalists to restore marine habitats and reduce disruption. Key systems and mechanisms. Operational excellence. As Maasvlak 2 evolved, technologies enhanced operational efficiency. Automated guided vehicles ***, these driverless vehicles transporting containers, improving speed and accuracy. Smart port technology. Sensors and software monitored real-time cargo flow, optimizing logistics and minimizing bottlenecks. Energy innovation ***, sustainability was integral, integrating renewable energy sources like wind farms, aligning with EU initiatives to reduce emissions. Difficulties and breakthroughs. Real-world challenges. The Maasvlak 2 project confronted logistical, environmental, and administrative challenges. 1. Environmental concerns ***. Local residents raised ecological issues, prompting design modifications and enhanced stakeholder dialogues. 2. Weather disruptions ***. Harsh North Sea weather caused delays, necessitating adaptive project management to keep the project on track. 3. Budget overruns. Rising costs led to stringent measures to mitigate overruns and safeguard project finances. Such challenges spurred engineering innovations, forging resilience within teams. Real-world impact and significance. A gateway to the future, the completion of Maasvlak 2 in 2013 marked a transformative moment for the Port of Rotterdam. The expanded facilities now accommodate next-generation vessels. With a depth of 20 meters, it can serve ships carrying up to 20,000 containers. Moreover, the project established a model for integrating advanced technology and environmental responsibility. By prioritizing sustainable practices, Rotterdam serves as a blueprint for future port developments. Closing, reflecting on a maritime marvel. Visitors observing Maasvlak 2 see not only the loading of containers, but the culmination of decades of innovation and planning. This port, a testament to exceptional engineering, embodies the forward-thinking needed to tackle global challenges. As trade and environmental issues evolve, the engineering decisions made here will resonate for generations. The narrative of the Port of Rotterdam highlights the importance of combining technology with ecological responsibility, a universal lesson for engineers worldwide.